Good evening, dear friends and students. Assalamu alaikum. It's me Alihan, and today we will talk about one of a good research paper recently published, that is mechanically strong and fully transparent PMMA composite with greatly improved toughness and impact strength incorporating PEBA nanofiber. This paper is published in the Chemical Engineering Journal and having effect factor is 15.1 according to 2023 and published in 2024. This paper is very important paper, and in this paper the author he synthesized polymer blend. He combined PMMA with PEBA. So furthermore, we are talking how they make polymer blend and how they did the work, how they mechanically strong and fully transparent PMMA composite he make. So outline of this paper is introduction, materials and method, result and discussions, conclusion. In the introduction part, polymethyl methacrylate PMMA is a widely used thermoplastic due to its strength, stiffness, transparency and biocompatibility. However, it lacks ductility and impact resistance, which limit its use in certain applications. So PMMA is a very good thermoplast because of its strength, but it is very lack of ductility. By minimum force you can break the PMMA, otherwise it is biocompatible, and nowadays everyone want to work on the polymer which is biocompatible. So we can improve this property by adding a rubbery material, but if we add a rubbery material, so like elastomer, so it will improve toughness, but also the other property will lose. But in this paper the author he add PEBA, so but in this paper he add elastomer and also some compatibilizer, and the interesting thing was that it improve one property and the other property is not reduced. That is the good point. So reinforcing PMMA with in situ generated rubber nanofibrous polyether block amide elastomer and selectively incorporating ethylene glycide methacrylate at the interface can significantly improve both tensile toughness and impact strength without compromising other property. The main thing is that when we PMMA is a very good polymer, it is thermoplast, high stiff, but the ductility is not good. So if we want to increase ductility of the PMMA of any polymer, so we will add some elastomer. So if we add elastomer, so the ductility will increase, but the strength, the stiffness will decrease. Like by increasing one property, the other will decrease. So that is the issue. In this paper, the author he try to improve ductility and never lost the stiffness. That is the interesting thing. That's why I want to make a video on this paper, and also I will highlight the key point of the paper. Maybe I will not explain every point in more detail. So if someone have any issue in any point, just email me. Email is mentioned in the introduction. Just email me. I will make video for them. Materials and method. So materials used in this paper is PMMA, PEBA, EGMA, acetone and tetrahydropurane. Experimental procedure. So the experimental procedure is very interesting procedure of this paper, very good. So preparation of nanofibrils composite and blend. In the processing step in the first step he used twin screw compounding. This is the twin screw extruder. Having the hole here is 24 millimeters screw. Okay, so first of all he take PMMA, PEBA and EGMA. He dry these three components at 90 degrees centigrade for 48 hours, and after that combine these three polymer and add it. Okay, first of all let's to explain this thing. What is this? This is a twin screw extruder. We are using this to make polymer blend. In this portion, this is the feed hopper. We can add the material which we want to melt. So we add the material here. Furthermore, it comes to this barrel. This barrel contains this screw. These screws are rotating and mix the material with each other well. This barrel contain heaters, different heater, a different portion they have heaters like these in both sides. It is in spherical shape, so heater is around from the barrel. So different heater have different temperature. At the end, this is extrusion die. The polymer which is made, it will be removed. So finally we understand what is this and how it's works. So when we add these material to the screw extruder, so in this barrel with high temperature from 120 to 220 and at the end 210 degrees centigrade temperature. So at high temperature and mixing, so it will mix at high temperature and finally it will be go out through extrusion. So the resulting substance contain 90% PMMA, PEBA 10% and EGMA about 2%. It is not 2%, is 0.6%. So in the first step he tried to make master batch. So in the master batch the concentration of PMMA is this, PEBA and GMA is different, and this concentration is can control from here. So he make master batch, and in this end when we add this sample, when the author add sample here, so this screw rotate is to rotation which is called RPM. So the speed of screw is 70 RPM and the feeding rate is 5 kg. Feeding rate is 5 kg per hour. After making the master batch, he tried to make fibrils using spun bond system. This is the same screw extruder, but they have this portion where we convert spherical droplets of minor component to fibers. That's why this is called spun bond twin screw extruder. Okay, let's to talk about this. So the obtain master batch first we dry at 90 degrees centigrade for 48 hours and also PMMA, and then the same process here we add to the feeding hopper and the temperature range from 180 to 240 degrees centigrade. The screw speed is 100. The speeding of this mixing is 100 RPM and the feeding rate is 0.8. Okay. So after mixing, melt and mixing, the polymer blend will go out. Okay. here is a question: why the author use master batch? Master batch usually we are using to dilute the small component, like PEBA is in the minimum concentration. We need to dilute it, but we need to disperse well. So for that, first we disperse in the PMMA, and then again when we make master batch, so again we mix with PMMA, so it disperses well. So that's why we are use master batch. If maybe someone have other idea, the idea which I get, that is this. So after making after making composite polymer blend, it will go out. So here this portion contain 92 holes. So when it go out from the spinner die, so this filament was then stretched and quenched. Quench mean to cool down using a stream of cool air blowing at 20 meters per second in the drafter chamber. The stretching of the filament result in the formation of PMMA nano microfibers about 30 micrometer in the diameter, and the transformation of dispersed PEBA in EGMA spherical particle into pine fibers. So here they show that the filament which is made, we will collect in the non-woven mat. Here we will collect the filament which is made, but in this portion it will stretch and the spherical part will convert to nanofibers. So the author he make so many sample which contain PEBA different concentration 0.5, 1, 3, 5 and 10 weight% of PEBA nanofibers. After that, like this picture, it show that this is the filament which is look like here is look like fiber is inside. So this filament is a PMMA filament, and inside they just show the fibers of PEBA. So different concentration of PMMA and PEBA nanofibers he synthesize, and after that they do injection molding at 160 degrees centigrade, which is lower than the melting temperature of PEBA. Okay, here actually the picture is there, so the video is there, so that's why it is hide, but okay, I will try to explain. This is injection molding. So for injection molding, the author would do it at 160, like there is 3 component, but the main component is 2, PEBA and PMMA. PMMA melting point is 160, so at 160 it will melt, while the PEBA has higher melting point, so it will not melt. So if PEBA they make fiber, so the fiber will not disturb, while PMMA we can reshape. So he make TNF, he make so many sample. First of all, TNFX, ternary nanofibrils component. It contains 3 components. One is PMMA. Here X represent the percentage of PEBA from 0.5 to 10. If here we put 3, it means that 3% PEBA, 0.6% EGMA, and the remaining 97, like the remaining 97% PMMA. BNFX, same X represent PEBA percentage. Binary nanofiller component, it means this component contain only 2 components, one is PMMA and one is PEBA. And TBX, X represent same PEBA, and this is ternary blend with there is no fibers. and then BB binary blend, which X percentage of PEBA, and binary blend it only contain two components, only PEBA and PMMA, and no other component like the EGMA is not present. Okay, here are a question arise, how he make this one. First of all, he make master batch, and the second step, when he want to make nanofibers, so what he do, he start experiment from here to here and make nanofibers. So this TNF contain fibers, BNF contain fibers, so he do all the procedure. But for TBX and BBX, which have no fiber, so when he start experiment from here, so he do up to 8, and from here he collect the sample. So he combine PMMA with PEBA and stop here. If he combine with EGMA and also stop here, so they will contain spherical PEBA and spherical EGMA inside the matrix. But if he do up to this one, so definitely in this portion it will convert the fiber, spherical will convert to fibers. Now further we need to talk about the result and discussion. So in the result and discussion section, the first graph is about DSC, diffractional scanning calorimetry. It is used, we do this analysis to check the melting point, transition temperature of the polymer. Melting point we denote from Tm, this is Tm, while transition while Tg show the glass transition temperature. So in this paper the DC result show that the actually the screen is very small, so that's why I need to look like this. Okay, so the DC result, it show that the melting temperature of EGMA is about about 197 round figure degree centigrade, and the PEBA melting temperature is about 197, and the EGMA is about 105, around 105, and the glass transition temperature of PMMA is about 93 degrees centigrade. So when melt blending two immiscible polymer, the size and shape of the dispersed minor, this is the minor component, PEBA. So the dispersed minor component are influenced by factors such as viscosity ratio, interfacial tension, shear rate, and concentration of the minor component. In the figure 2b, it is the complex viscosity of PMMA, PEBA, and EGMA, because we combine these three components in the polymer blend. At temperature 240 degrees centigrade, as shown as a function of angular frequency. So all material typical exhibit typical shear thinning behavior, with EGMA show more pronounced effect compared to PMMA. It show more pronounced effect as compared to PMMA and PEBA. So the viscosity between PMMA and PEBA at shear rate of 100 per second, 100 and 200 per second is calculated by applying Cosmer's. It is the rule. Sorry, I did not mention the name here, but I need to mention next time. I will mention this name. So it is the rules called Mars rule. So they get values 0.79 and 0.89 respectively. So it indicating the potential. So it indicate the potential for uniform dispersion of pine PEBA. Because the value is 0.79 and 0.89, so the uniform dispersion of pine PEBA spheroid across the PMMA matrix volume during the mixing volume during the compound process. So the dispersion is well. From this data we can get this result. Furthermore, the Harkin spreading theory. So the application of Harkin spreading theory in the supporting material, they also mention some graph, but I take the only one which is main and which is, I think it is sufficient. So Harkin spreading theory in our ternary bell system, as shown in figure 2c, predict the development of a partial wetting morphology with AGMA assembling into droplet at the interface between PMMA and PEBA. Furthermore, the figure 2D is usually represent the contact angle measurement of water. Water is a polar, and DIM, diachloromethane, is a non-polar liquid. So on the different polymer surface, so we check the drop on the polymer surface and see the contact angle. Lower contact angle mean more good, more dispersion, more good. No, because water is polar, PMMA is non-polar, so non-good, no good interaction, while they have good interaction with the non-polar solvent. So it show the wetting behavior inside the polymer. Furthermore, figure 2e present the ATR-FTIR spectrum. So okay, in the next this is ATR-FTIR attenuated total reflectance Fourier transform infrared spectroscopy. So in the previous slide, this is the same graph, just I take screenshot and paste in the next slide to explain in detail. So this AT-FTIR measurement were conducted to study potential chemical reaction during high temperature melt blending of PMMA, PEBA and EGMA. So figure 2e, this 2e, it showed the ATR-FTIR spectrum, which show some absorption peak, which some absorption peaks are identified, which is important. Like in PMMA, absorption peak at 17 around and 1723 wavelength. This peak is it related to the ester carbonyl group CO. Carbonyl contain ester group another peaks are also related to CH2 and so many, but this is very important. Second thing, in PEBA, the amide 1 C double bond oxygen stretching vibration here, okay, here it also shows stretching vibration of ester carbonyl group. In this PEBA at 1635 wavelength, it show the amide carbonyl group stretching vibration, and at 32 167 wavelength, the NH group, this is the NH group, it show the stretching vibration of NH group. Furthermore, in the EGMA, this group at 2848 and 2915 wavelength, it shows the symmetrical and asymmetrical stretching vibration of CH2 group of CH2. This both symmetrical and asymmetrical stretching vibration of CH2 group. Notably, the amide group, NH group in the PEBA here, bending vibration peak of PEBA initially located in around 1555, but due to red shape, it shaped to 14 in the composite, in the polymer composite, it shaped to 1544 in the spectrum of TNF10 of this. So this shift can be attributed to the formation of hydrogen bonding, which weaken the NH bond and cause a decrease in the vibration frequency, result observe red shape and observe red shape in the peak. Furthermore, absorption at 911 here is a small absorption detected in the GMA, which show the epoxide ring stretching vibration of COC, stretching vibration at 911. So which it is detected here, but in this portion it is not clearly, we cannot see clearly. So that's why to address this issue, to identify where is the peak, so the ternary system we remove PMMA from the composite to see we etch PMMA with acetone to see this peaks, where is it, what he is doing, how we can see. So let's look here to figure out the issue. So figure 2F and S4, it show the ATR and FTIR spectrum of each sample. Here we etch PMMA with acetone. So looking to the graph, so in this sample we clear, so this sample is presence of EGMA and also without of EGMA. So we so the author did the FTIR spectrum. So here a clear 911 a clear peak observed, which is related to the epoxide ring, while here is not present. So it means that may be possibly due to the epoxide ring of PEBA, it start reaction with the hydroxy group of PMMA and epoxy group start reaction with the secondary amine of PMMA. This reaction is very fast and this is very slow. It is a secondary amine, this is very slow. So it is possibility. So during the compounding process, these reactions happen, so that's why the peak of epoxides are disappear. And also here we see the they also make some another bond, hydrogen bond was also observed, and this also. So this is the interesting point, that the peak was disappear. So it make they are involved in some certain reaction. Okay. Furthermore, look to the morphology, SEM images. So these SEM images of fracture surface of binary blend. Binary blend mean two component PMMA and PEBA. Contain 3%, 5% and 10% PEBA, and so the result it show this is the matrix. It contain this is PMMA and the droplets are PEBA. So in all concentration the dispersion as well. It shows the dispersion, the uniform dispersion of PEBA droplet throughout the continuous PMMA matrix volume is very good. So in the histogram, we see in the histogram figure 6, it illustrates the diameter of PEBA droplet. It is for 1%, 3%, 5% and 10%. So histogram show the diameter distribution of PEBA droplets within the blend. With increased PEBA concentration leading to corresponding increase the droplet diameter and wider droplet diameter distribution. The final product diameter distribution is shaped by factors such as droplet breakup, droplet coalescence, and the escape of large droplet from high shear region. All of which become more frequent with higher PEBA concentration, and they show different different mean value. You can see actually I did not see more because I did not use Mac video, so that's why don't know how I can zoom. Maybe later I will learn and I will do it. So you can see the values here. As it increase, so the size of the particle also increase. So figure D to F display the morphology of ternary blend where EGMA, this is the three component where EGMA is positioned in the interface of C island, and the interface of C island, these are the EGMA as position in this portion. As predicted by Hawkins spreading theory, the EGMA droplet exhibit here it exhibit a strong adhesion to the PEBA droplet, which almost all EGMA droplet remaining firmly attached to PEBA droplet even after fracture surface. Certain EGMA droplets adhere to PEBA particle A are elongated upon fracture. Fracturing, confirming the occurrence of chemical reaction between PEBA and EGMA during compounding process as shown in figure S8. In the compatibilized blend, the drop size of the minor component is influenced by interfacial tension and viscosity. The addition of compatibilizer typically reduces the interfacial tension, result in the small droplet. However, if the compatibilizer contain reactiocyte like epoxide ring which react with the minor component. It can increase the viscosity ratio and lead to larger droplets. In figure 9, the average size of PEBA droplet within the PMMA matrix comparison of ternary blend and binary blend remain nearly the same when EGMA was added. This suggests that the reduction in the interfacial tension by EGMA was balanced by increase in viscosity ratio, possibly due to partial wetting, which can lead to more uniform and binary and pinfibril. In the spun bond, processing, the extrudate undergoes stretching, as I mentioned in the experimental portion. Stretching and rapid cooling by high velocity cold air, causing dispersed droplet into deform, elongated, and coalesce into an integral fiber morphology of high aspect ratio fibril. The extent of the droplet fibril transition and the final nanofibril diameter are influenced by factors such as viscosity ratio, fibril fiber coalescence, temperature profile, screw speed, feed rate, spinal hole diameter, and air velocity. So in the figure, in the figure 4, it shows the ECM images of nanofibrils. This is the PEBA. This is the HSH sample, but it is partially H sample of composite. This is H ternary nanofiber composite containing 3%, 5%, 10% PEBA nanofiber. Exposed PEBA nanofiber are wrapped around large HA. So the results show that after etching with tetrahydropurane, the PMMA microfibers were partially removed, revealing the PEBA nanofiber. The successful conversion of PEBA droplet into fiber is evident. This fiber is the evident. However, it was challenging to distinguish EGMA nanofibers due to their similarity to PEBA nanofibers in size and interface. Figure 10. It shows the histogram diameter distribution. So the distribution of PEBA nanofiber diameter in ternary nanofiber composite ranging from 20 to 230 nanometer. The average diameter of 60 plus minus 30, 66 plus minus 31, and 75. These images show the size little bit more clear and zoom, so that's why I can see. So you can also see the previous one which I mentioned, that you can see the size of the droplets of the PEBA. But here in this portion, the author mentioned that we cannot distinguish between PEBA fibers and EGMA, but it is a compatible. PGMA is a compatibilizer which make good attraction with both of them. So, okay, our main the researcher main target to make fibers. So histogram, it showed that the range of fiber 60-64 is the concentration increase, so the fiber size diameter also increases. In figure S10 show the histogram, and S11 so S11 here, this is the morphology after. Wait, what's happened? Sorry, something issue in the system, so that's why they show disturbance, and when I click on the notification, so the video stop. Sorry. Okay, so figure is 11, it shows the morphology of the blend when if you remember the experimental portion. So in the experimental portion, after making the uh, composite material, they did injection molding. So in the injection molding, they used temperature 160, around 160 or 65. So after injection molding, the morphology of ternary nanofiber composite with the 3 weight% of PEBA nanofibers remain fibers after injection molding at 165 degrees centigrade, and the average diameter slightly increased to 108 plus minus 43 nanometer. It attribute to the partial relaxation of the nanofiber from high temperature and shear rates during molding. In figure S12, histogram depict the diameter distribution of PEBA nanofiber within the binary nanofibrils composite, while figure 9b, I take from the previous slide 9b because it explained here. Usually compare average nanofibers diameter internally and binary nanofiber composite show no statistically significant, no changes we can no changes was observed. Big one you can see here. So this is not almost same, so no big changes observed. Furthermore, next characterization they did rheological property. So for rheological property, figure 5th A and 5th B show elastic modulus and loss tangent. When PEBA nanofibers incorporated into PMMA, it is PMMA and this is the TNF and with very concentration. Same is also PMMA with very concentration of PEBA and EGMA. So when PEBA nanofiber are incorporating into PMMA, the elastic modulus gradually increase and the loss tangent decrease at low frequency. It decrease at low frequency. This effect is more pronounced with a higher concentration of PEBA. So the effect is more pronounced with higher concentration of PEBA like this is the higher concentration, and this one is also the higher concentration, like TNF10. Indicate the transition in the stress relaxation behavior of the material. While figure pipe D and figure pipe E, it is elastic, modulus, and loss tangent per ternary blend. When PEBA is dispersed in the is spheroid like a spherical shape, spheroids in the ternary blend. So we can see there is no significant changes, variations not noticeable. There is no significant change observed in the elastic modulus and the loss tangent modulus. And figure pipe C and pipe F, it is log G prime and log G prime, double G prime. So the ternary nanofiber composite exhibit a decreased slope, both show a decreased slope in the terminal region with an increased concentration PEBA nanofibers at apex temperature, indicate different structure effect compared to the ternary blend where PEBA is dispersed and spheroid, and as compared to the where PEBA is dispersed as spheroids. So it has different structure effect. Like there is the fibers, there is no fibers, so that's why a lot of difference. Okay. Furthermore, figure S13, it show rheological data of binary nanofibril composite showing lowering G prime value for composite without EGMA, which has no GMA, it show lower. In both PEBA nanofibers and EGMA, the tan theta curve for composite without EGMA remain. So this suggests that the EGMA remains strongly bonded to PEBA nanofiber, possibly also in the form of nanofiber rather than existing as a separate droplet within the PMMA matrix. Okay. Furthermore, looking to the very interesting property, that is optical property. So the transparency of material like this transparency is depend on the refractive index and the concentration of the nanofiber as well as their diameter. When the diameter is much smaller than the visible light and the concentration is low, about 3% or less, transparency can be maintained even a refractive index mismatch. Figure A to C. These figures show the material up to 3%. These results show that the material up to 3%, up to the different concentration, show different color, show different concentration. So up to 3% fibers are nearly transparent. If the composite contains 3% PEBA, so it is transparent as per PMMA in the visible light region. About 500. When the PEBA nanofiber content was increased up to pipe and tin, so light transmittance value dropped to around 85 and 80 respectively in both the binary and a binary, and also in the ternary blend system. This decrease is mainly attributed to increase in entanglement degree of the nanofibers at higher concentration. Figure 6c and figure S14 also exhibit a high level of light transmittance comparable to that nanofiber composite. So if we so the author mentioned that in the visible region up to 3% it's transparent. So okay, further in the S15 we can clearly see that this is PMMA, where it is good transparent result. This contain 1% PEBA, this contain 3%, and this pipe and this 10. So if we look to both them, the result is good, more transparent. But we increase the, even pipe is also good, but increase the concentration. This is the contain fiber, it's contain fiber, but still more transparent, more good result. But if we compare with the blend, which is ternary blend, which contain spheroid of PEBA, so the transparency affected is not good transparent. Ternary blend hazy is just 1%. Okay, PEBA. Figure 6d show the haze value of binary and ternary nanofiber composite. Composite increased slightly with PEBA concentration reached to 25 at 10% weight. When it contained 10% P, this is PMMA, so when it contain it up to 10%, so the value is reached to 25. 25 is very low. The haze is 25. Up from 11% per PMMA. However, there is a significant spike in the haze value of binary and the ternary blend at 1%. At 1% PEBA reaching 90%, reaching 90% at 10 weight percent PEBA. Okay, sorry, blend at 1%, reaching 90% when it is 10%, so the result will be 90% hazard. This when the concentration of PEBA is around 10, so the haze effect, so it is about 90%. So in the next graph, that is figure 6e, UV transmittance decrease, UV transmittance value decrease significantly at PEBA concentration increase from 68% to 15%, and the PEBA concentration up to 10% per all system. However, at low concentration to up to 3%, we'll take 3% or less, the drop was lesser, with TNF exhibit a UV transmittance of 45% at 300 nanometer. Further, the next slide explain glass transition temperature. So in this system, the PMMA has glass transition temperature TG 92.8 degrees centigrade. By incorporating PEBA, the TG increase. Here is a question: by incorporating elastomer, rubbery material, it need to decrease, but it is so. In this paper, the interesting thing is this: by adding nanofibers, the TG of composite material TNF, it increased, it is reached to 95 degrees centigrade. So it indicate that the PEBA fibers, it role as a rigid pillar. That's why TG increase. Figure 7b, when PEBA was dispersed, a spherical particle with EGMA, the TG remain comparable to that paper PMMA at all concentration. Like here, the same blend, both are same, but here the blend is made which contain fibers, but here is no fibers. Here the dispersed medium is in spherical, while here the dispersed particle is in fibers. That's why here TG increase little bit more, but here is no. Furthermore, looking to the mechanical property, it is very important for polymer blend, for polymer. So figure 8a show the stress strain curve compared to the tensile property of ternary nanofiber composite. Paper PMMA show brittle fracture characteristics, while the ternary nanofibers, while the other ternary nanofibers composite exhibit ductile fracture behavior with a distinct yield point and necking before complete failure. Second graph, figure 8b. Figure 8b show elongation at break. By adding a little amount 1% of PEBA nanofibers, double the elongation at break, reaching about 14.6% and slightly increase with higher concentration. Slightly increase. And reaching about 16.5% with the 10% of PEBA concentration. The inclusion of EGMA in this portion, it contains EGMA third component, compatibilizer. Because of compatibilizer, the TNF reaching about 18.6% and the same concentration. So it is more higher than the PMMA and BNF binary the binary composite. Figure 8C and D. 8C and D show ultimate strength, tensile strength and young modulus which decrease with higher, it decrease with higher PEBA concentration, with TNF 10 show is an 11% decrease. TNF 10, it show 11% decrease and 10% decrease in the modulus, and 10% decrease in the modulus compared to PMMA. However, TNF with low PEBA nanofibrils around 3%. TNF which have only 3%, showing minimum changes in the strength and modulus compared to PMMA, similar to BNF, BB and TB. Figure E. Figure E shows the addition of PEBA nanofiber alone substantially improved tensile toughness, little bit improved, but had minimal impact on the strength compared to PEBA. However, combined PEBA nanofiber with EG may greatly enhance impact strength. TNF3 exhibit the highest impact strength at 17.34 joule per mole, 87% higher than PMMA. No significant improvement in the impact strength was observed in the binary. In the binary, no significant improvement was observed in binary or ternary blend. Only this one good show result in the radar in the figure 8.5 and table S4. So this show comparison up with previous data. So in the radar diagram, TNF5 containing 3% PEBA nanofibers and 0.6 weight% EG may show significantly improve elongation at break. How much? 169. Here you can see from table in this current work, this work 169. And impact strength is 87% compared to PMMA, and tensile strength, stiffness, transparency, performance comparison against published literature data present in table and the remaining data shown in the paper. Okay, I think this is the okay. So furthermore, the toughening mechanism. So figure 9A to C and figure 17 ECM images of fracture surface show numerous so many crazes. So the line show crazes in cavitation. This is cavitation. Crazes in void in TNF3 and B binary nanofiller, explaining their improved toughness. In contrast, the ternary blend in the ternary blend had fewer crazes and more prominent cracks. This indicates that the PEBA nanofibers are more effective in initiating and ending crazes than spherical PEBA particle. In figure 10A, it is SAXS, small angle X-ray scattering pattern. A fracture sample show higher crazing. So it show that the crazing is very high in TNF3, very high as compared to PMMA, BNF3 and undeformed TNF3, which is undeformed. So this suggests that TNF3 higher toughness is due to more craze initiation and control growth. The presence of EGMA at the matrix nanofibers interface initiate more crazes and control their growth, resulting in uniform crazing across matrix. Figure 10B. It is little bit different. 10B and table S. So 10B, it showed the one dimension 1D SAX small angle X-ray scattering measurement plot generated by integrating the intensity of 2D SOX pattern between azimuthal angle of -25 to 25 degree equatorial direction. So the 1D The 1D Sachs plots offer a quantitative basis for comparing the scattering pattern. The relative invariant Q, which is proportional to the total volume of craze, which is calculating using data from 1D Sachs plots. The value of Q is listed in the table S5. So notably, the invariation Q for the fracture TNF3 was 7 times higher than the fracture PMMA and 3 times higher than that for the fracture BNF. Figure 9D to F. The impact strength of TNF3 was highest at 3%. Like the impact strength was very high when the concentration was 3%. Here is the D, where is D? D, TNF3 3%, B binary, and TB it contains spherical. So it decreases at higher concentration due to nanofibril agglomeration, so the strength will be decreases. The ternary blend and the binary ternary blend did not show toughness improvement as their rubber concentration was too low. The fracture surface of ternary blend show large droplets. Indicate the nanofibers maintained there. This is the ternary blend. Which one? Ternary blend F. This one. It show the large droplet indicate that the nanofibers maintain their shape after injection molding. I think this is the second last slide. Stretching behavior. So we check the stretching behavior of the polymer. So in the figure 11, it shows the scratch morphology and longitudinal section profile of scratch groove after elastic recovery are shown for different normal loads 4, 6 and 10 micronewton on pure PMMA. It is for pure PMMA. 1. Second, ternary nanofibril ternary blend containing 3% of PEBA spherical, and this one is contain nanofibers, ternary nanofibril blend, and the last one is ternary blend and a different nominal load 4, 6 and 10. So the scratch depth of the scratch on the TNF3 this is power, this is TNF3 and this is TB3. So the scratch depth observed on PMMA was recorded 67. In this is recorded 67 plus minus 2 nanometer at 4 and 116.20 The scratch depth of TNF and TB3 were lower compared to PMMA under low normal load and 4 and 6. It indicating the improved stretch regime. Here the stretch it show more resistant to stretch. Here is the stretch easily do scratching, but here the scratch is difficult. So table 6 it show the different scratch depth at different uh, per micronewton pressure. This one, the applied force 6 micronewton, and this is 10 micronewton. Conclusion. So the study in this paper, the study showed that both the tensile toughness and impact strength of PMMA can be enhanced together without sacrificing other important property. As I mentioned at the beginning, in this paper is very interesting. Why? Because it will not sacrifice any other property, and the toughness, tensile toughness and impact strength will be improved. The composite consists 3% PEBA nanofibers and about 0.6% EGMA distributed uniformly in the PMMA matrix. This composition results in significant enhancement in elongation at break, tensile toughness and impact strength compared to pure PMMA. Also in other some paper I see that 3%, around anything up 3% have good result, especially for fibers. The last point, incorporating EGMA at as interface was crucial for improving both tensile toughness and impact strength simultaneously. EGMA act as additional crash initiation site, increasing crashing density at slow deformation speed, and promoted rubber cavitation and ductile shear yielding under high deformation speed. So overall conclusion is that one point I mentioned about the property that the strength, tensile toughness and impact strength was improved in this paper. And the second point important, that is percentage. So 3%, if your matrix contain 3% fiber, so the result will be good. Maybe in your case, if someone is trying, so maybe other concentration will have good result, but in this paper 3% give good result. Okay, so thank you for listening the presentation. This presentation I start initiative to make papers presentation for students. I am not a good presenter, but I will try to present paper well. So if someone have any issue in the paper, so in this paper if someone did not understand from this presentation, so please send me email and mention the thing, so I will try to make another video for you and I will explain the point in more detail. Like here, as I mentioned at the beginning that I did not mention everything. Like in this paper, I just highlight the key points, what the result which I get, the idea which I get. So I discuss with you, and it about take more than 1 hour. So if I explain every point, so it will take a lot of time. That's why if you have any issue, maybe I explain the idea which I get, I explain with you that if I'm a human, if I did something explained wrongly, so sorry for that. But still, if you got any mistake, you can send me email, I will correct it. And furthermore, if anyone interesting to have trouble in any portion, so please send me mail. And second thing, if there is any paper when you are facing any issue in any part, so you can send me email, you can send me the name of paper, so I will make presentation for you. And I hope that you will get something from it. And thank you.